Okay, so we are going to talk about functions today. And what I'm going to do first, I'm going to start from kind of second semester, quickly go through a few things that we need to know about second semester. Like what I'm going to do, I'm going to first create a problem. Then after I create a problem, I'll tell you how C++ solves that problem. Going back to OOP345, we used to write functions to be able to learn how to put C in and C out. We used to write foolproof data entry functions. So say we had some function called int get int, something like that. And then we would write that function like int get int, something like this, and return some kind of a number, and that number is something that we have in here, int num. And to make this get int number do a foolproof data entry, what we did, we created some kind of a condition over there, say done is equal to false. So that's going to let us know when we are done with the data entry. Then I'm going to say keep doing data entry while not done. So essentially, this repetition over here is going to keep doing the data entry for us, and when we are done, we're going to set the done to true, and we're going to go out. That's the standard way of doing any type of user interface. So essentially, in a loop, you keep talking to the user until the user actually enters some sane information, and then that's when you're going to go down. Then what we do over here, we simply say, okay, let's read the number. And when we read the number, we check to see if CN is satisfied with the data entry. So if it fails, that means something went wrong. If it's not, then I'm going to continue with my data entry. That's very simple and straightforward. Obviously, if CN cannot read it, first we apologize, say sorry, user entered something dumb. Apologize, let's now talk again. And we tell to the user that, hey, you entered some invalid integer. Try again. And I don't know, something like this, and show a prompt. And if user, and obviously, so we have two cases over here. Either user enters something perfect, so enters 55 and hits enter. In that case, num is going to get the 55, and I have one backslash in a buffer. Or user enters something stupid, and there are lots of garbage in the buffer. In any case, I can do a flush after the whole thing. Even if it's a good thing, if even everything is perfect, I at least have one backslash in to remove. So in here, I'm going to say C and ignore, I don't know, some humongous number, and then stop at backslash in. Something like that. So that takes care of anything that remains. Now, if it actually reads, now I have to check to see if they only entered an integer. Maybe they entered 55 and then ABC. If that's the case, that's not a valid number. If there is anything after the integer, I need to check that. So I need to take a peek and see what's coming next. So if CN taking a peek to the next character, and that one is not equal a backslash n, it means they did not hit the enter and they have some garbage after. Else, in here, everything's good. So now, if they did something like that, obviously I'm going to say, hey, only an integer. Integer. Only an integer. 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 Only an integer. Please try again. Or try again. Go to new line and show a prompt. Okay, so if it's here, then I have an integer and only an integer. that there cannot be any garbage because it means it's ended with \n and everything's fine and dandy. At this moment, I have a good integer, but do I have a valid integer? Depending on what I'm doing with this getInt, I don't know, we can have different types of functions written for this one to tell us what is good or what is bad. If I want this person to be an adult, then I need to have some kind of a validation for an adult saying, hey, this is supposed to be greater than or equal 18 and less than 65. If it's less than 18, it's a juvenile. If it's more than 65, it's a senior. It's not an adult. So that's it. But if the number validation is for valid number of students, then between 10 and 35. If it's below 10, no class is going to be created. If it's more than 35, too many, we haven't opened a new section. So that's that one. So now, in the everything good part of the section, I need to actually check to see if, for example, it's an adult or something like, it's an adult or something. So I do something like, if it's an adult, then done is done. I'm good. Everything is good. The condition met the function that we had up there. If it's not, I'm going to say no children or seniors permitted. Then I'm going to go back up. So that's how the foolproof entry happens, and everything is fine and dandy. Are we okay with this? Very quick and straightforward. So what's the problem with this code? Nothing. It works perfectly. The problem with this is that my getInt cannot be a generalized function. So when you think about it, if I want to have some getInt in here, this is an adult, right? If I want to be number of students, either I have to take the as adult out from here and insert the other function and recompile the code, or I have to write separate integer entries. Write one something called get age, get adult age, and the other one's going to be get a number of students and call the getInt with the proper thing in it. So my getInt cannot be changed from function to function, from scenario to scenario, without recompilation or creating new functions for every single thing that you have, entire data entry functions. That's our problem that we want to fix today. We good? All right. So, and obviously in here I can have some kind of a data entry thingy to test the program. I'm just going to run it, make sure it compiles. I don't want to have something that is error in compile. I'm just going to go with the compilation. And we're good. Okay, so it's working. I'm not going to go through it. You know what it is and what it does. Everybody's okay with this? Online people, are we okay with this? If we are not okay with this, activate the microphone and say something. I don't see the chat session. If you have a question about this or anything that is wrong over here, please let me know. Thanks, Victor. I got a thumb up so I can see something's good. All right, so now, so this is going to be, I'm going to call it 244 getInt. All right. Now let's go back to C language. So although what I'm going to write over here is C++, but this is actually C. It has, it's not specifically for C++. So just be aware of it. But we've never used it. It's considered being advanced thing, so they never taught it in IPC 144 or OOP345. Say I have these two functions in here. Oh, not that one. Say I have these two functions in here. Now, can someone tell me either from home or here, what is common between these two functions? What would you say if you wanted to say? There are
two integers.
they both receive two integers?
They both receive
Two integers, and?
They both return nothing.
And then they both return nothing. Okay, so what does that, so that's beautiful. What do we call that in C language? They have the same. They have the same. Hello. Signature, thank you. Okay, they have the same signature. So they both have the same signature. Essentially, signature of a function means if you take the name out, they should be identical with, and they have the same. Beautiful. Okay. So if you recall, when we were talking about pointers in class, I did a quick review on pointers, and I talked about arrays and pointers. We said that when you are talking about an array, when you actually look at an array is essentially a piece of memory with one pointer pointing to the beginning, right? And the square bracket in front of the pointer is actually an operator that adds to the address of the pointer, and therefore you can access the elements. Remember that? Okay. So I would love to. What can I do? Let me just try something. I'm going to bring this one over here. And this one over here like this. So we can see people over there too, as if you are in class. So at least when I'm talking, give me a thumb up or something so I know that you are actually hearing me, okay? Because when I'm standing over there, I need to see who's talking. Okay, so, and it would be nice if you activate your microphone and answer. Yeah, so as I was saying, we said that arrays are essentially a pointer pointing to a piece of memory. And that piece of memory is where we hold the data. Therefore, using the name of the array and the index operator, I access the data to which the pointer is pointing. Are we okay? People at home, can you do some thumb up or something when I say, are you okay? So I know, there we go. Thank you, Son. Okay, fantastic. So that's that, so we know that. Now, I have news for you. A function's name works exactly like an array's name. It holds the address of the beginning of the logic in memory. So array's name holds the address of the data in memory, array of integers, array of cars, array of employees. But a function name holds the address of logic in memory. So if I write something like this, and execute, as you see, I'm writing over there sum. I'm saying reinterpret cast. Sum, we said sum is a pointer. Because it's a pointer, when I print it, it's going to be some hexadecimal value. Okay? We could actually do that. We can just show the sum as sum itself. So I'm going to go over here, see out sum. Okay, and then cast it to at the same time. And when I actually run this program, you will see that it actually shows something like this. So this is the hexadecimal value, and this is the converted to the long. So as you see, it has some address in memory. Okay, so now it has some address in memory, we understand. So how does the compiler call it? How does the compiler call it? Compiler calls this using the function call operator. Square bracket was the index operator. Parentheses are function call operators. So if I put in front of that pointer a pair of parentheses, I'm essentially telling to the compiler, to the C language, call this function. Now, and obviously the arguments that I put will be passed to the function. Are we good? So if I could somehow create a pointer that matched the signature of this function, I could use a pointer to call the function. So how do we create a pointer? If I have an integer and I want to create a pointer out of it, I put an asterisk in front of it, right? So in here, if I want to create a pointer to one of those functions, so this is, let's call it func pointer. So func pointer I want to create. So it should have the same signature of the function, which means int and int. That's the signature, and it should return the same thing. But wait a minute, this is not a pointer to function, it's a prototype of a function. So this doesn't work. Oh, we said we put an asterisk beside it. So if I put an asterisk beside it right over here, as soon as I put an asterisk beside it, the compiler says, oh, that asterisk doesn't belong to name, it belongs to void. Again, it becomes a prototype for a function that returns a void pointer. Now even the signature is different with that one. To make that asterisk stick to the name of the pointer so it can identify this as a variable, you put it in parentheses. So essentially, I would say, hey, this void belongs to the name, not the type. Now, ladies and gents, that funcPTR is a variable. It's a pointer to a function, any function that receives 2 integers and returns nothing. So I could bring, so those two are actually showing sum and a product of 2 numbers. I can write another thing, write something like void, I don't know, repeat, and in here I can say integer num, and in here say integer value, and I can go for integer I set to 0, I less than num, and I plus plus. I can do this if I is not equal to 0. I'm going to show a comma. Other than that, I'm just going to show the number. Okay? Completely different logic than the other ones, but signature is identical to that one, right? So these are all 3 functions with the exact same signature. So now, take a look. This funcPTR is a pointer, right? I can actually do this. I can say funcPTR is set to sum. So obviously, if I put over here funcPTR, it will be the exact same address as the other one. Right? As you see, the addresses are identical because I set it to that one. But if the addresses are the same, then I may be able to use funcPTR to call sum. So I'm going to say over here, func. So let's bring this down. Yeah. So in here, I'm going to say funcPTR, PTR, and I'm going to call, say, 10 and 20. And I run the program. There we go, 30. So it actually called sum. Now that I have this, I can do even better. I can change it to whatever I want. I can say now funcPTR will be set to prod and exactly call the same thing. And this time I'm going to say is set to rep, and I'm going to call the same thing. So I'm going to call the same. So literally the function calls at line 25, 27, and 29 are identical. But when I run the program, I'll see that 3 different functions are called. The first one is sum, the second one is the product, and the third one is repeating 10, 20 times. 3 different functions. How do these work? How do these work? It works as follows. So the variable is created, and as you see, it has garbage in it, which is 71 over here, whatever it is. Then it will be set to sum. Now, if you look at funcPTR, it shows the address, and it says 06Sep30.exe exclamation mark sum. That means the function sum that is in the executable. So it has the address of that one. It actually tells you which address it's holding. And now, these are obvious. Now, let's bring this over here. When I want to call this, it actually goes to sum and executes sum. Now it comes down. Now it holds the address of prod. So when I call that, it goes to product. And now it holds the address of rep. And when I call it, now it calls the repetition. We okay? That is called pointer to functions. This is an absolute disaster for object orientation. It's pure C. Like I'm literally not only, like we used to have functions at least in C language. Now we are even saying functions can be pointed with different things. So it's not methods, it's address of a function. We good? Okay, so now that we have this, now that we know function to pointer to functions, so this is going to be func ptr. I can use this to do something pretty cool. So let's go back to our, we are in section NRA. Let's go back in here. I'm just going to copy the whole thing and bring it here. Okay, so the validation function signature is identical between the two, obviously. It's checking, getting an integer, checks to see if integer is valid and returns it, right? What if I pass that as an argument to the getInt function? What if I say over here, hey, the getInt function receives a Boolean validation pointer is valid, let's call it, that receives an int. So essentially, that is valid becomes a pointer to any function that receives an integer and returns a Boolean. Now, I'm going to bring that over here and add it to the function definition. Now, in here, instead of calling isAdult, I'm going to call isValid. IsValid returns an integer, returns it, and receives an integer, and returns a Boolean. So it's a perfect match for this. Now, if I go up in my code, I can say, hey, getInt needs the validation isAdult. I don't call the function. I pass the address of the logic. Now I can easily use the exact same logic. And I say enter number of students. And in here, I can say valid number of students. And I'm going to say number of students in class. And I'm going to change the age to another variable, say NOSTNO, and this is going to be STNO. So as you see now, I can actually use the exact same function logic, passing external logic to the function so it can use it internally. Are we okay with this? So now, for the first one, I'm just going to add a stop sign right beside where the function is called. When I run this program, it wants the name. I put over here 300, and I'm going to hit enter. It comes over here. It passes 300 to isValid, but isValid holds the address of isAdult. So it goes up to isAdult and creates that validation, and therefore it's going to say no children's permitted. Run it again. Oh, no children permitted. So I'll put over here now 30 and I hit enter. It comes to is valid. 30 comes over here. So again goes to is adult. And now it accepts it and comes out and it's going to say age is 30. And when I run it again, number of student, I'm going to say 100 and I hit enter. It calls is valid, but is valid is now valid number of students. Therefore, it goes over there and calls that one and up. So the error message is bad now. You see that? It says no children and seniors permitted for all of them. So we have to generalize that too. So instead of no children's or seniors, I need to say something like, what do I say? I'm going to say invalid int. Invalid value. Try again. I cannot give them any help because, again, I cannot give them any help because the error message is not custom. Okay? We'll fix that in 2 seconds. But anyways, we saw that we can call different functions. And now it comes over here. If I put over here 20, now 20 is acceptable. And it runs it. And it's going to say number of students is 20. Okay? So we just did the function pointer in use. Step 1. Or, step 1, or first example, that's it, in use.cpp. Now, what I will do, I'll go back over here and take a look at PRG and see how can I fix this. So now I have the freedom to design my getInt to accept any type of function. And I can document it. Hey, if you want to use my getInt, your validation must do such and such. So why don't I ask them to create the isValid in a way that it receives a string. And I can say over here, isValid receives that one and a string reference. Okay? And over here is the same thing. String reference. And then what I will do in here is create something like this. String error message. And set it to empty. And over here simply display the string. Now I can ask whoever is designing the function to receive a string. And set the value to whatever it's supposed to be. So in here, what they're going to do is saying Boolean result is set to whatever it is. So that's the validation or valid. Okay, and then I can say if not valid, then error is set to, what do we set it? Values between 18 and 65. Try again. Something like that. And for the other one, I'm going to say Boolean valid. Now, here is a condition, but this string result error if not valid, then I'm going to say error number of students must be between what, 10 and 35. Try again. Now, obviously, I have to return the valid thingy that I forgot to do. Return valid. And the same thing over here. But what I wanted to say was, in here I have one-liner functions. But imagine that the integer you are receiving is a student number. In this validation, you can connect to the database, search the database, see if the student number is there or not. If it's not, then you return false. So what happens inside this thing could be huge. And here is just a sample example. Now my functions are custom. They are actually giving custom error messages for whatever the value is, and therefore, build error. What do I have in here? Too few arguments to call the, in here I have to pass the error message. Is valid an error message. So essentially that is setting the error message if anything goes wrong. Age, I'm going to put over here 2. It's going to say valid value. It's like that. So I'm going to put 60 now, 50. It's going to say you're 50. Number of students, garbage. Invalid integer. 23, yeah, something, only an integer, please. And then I'll put over here 50. Now it's going to give me the error message. Now I put 20. Everything's good. So now, as you see, pointer to functions come and play in a very nice way. It's a good thing to know this in IPC 144 if we had an advanced one, something that we can actually go through, because this is a C case. Like if you ever are writing a program in C language, and you will, there are some things that there need to be written only in C. This is an amazing feature you can use in C. One difference you need to remember, in C language, so if I wanted to call this function in C language, which works in here too, it's called like this. In C, like when you create struct, you have to say struct at the beginning. When you create a function pointer, so you can do like this. So in here, I'm going to say calling it C style. Calling funcPTR C style. The C++ style works. It doesn't make any difference. But I'll comment it. So you know they both work. So in here, I'm going to do it like this. This is C++ style. Essentially, a function pointer can act like a pointer, but in C, it is called like this. Both work. It doesn't make any difference. So if I run this, it's going to work exactly the same way. Absolutely no difference. If you are doing C, do it that way, please. So I put over here, I don't know, it's going to be, so it works. That's all I'm saying. Okay, so that's that. So in here, I'm going to say, that's C, and I'm going to put this one D. We're good down to this point? Another thing to know is that because this is literally a variable that you're creating in here, okay, it doesn't matter. You can actually create an array of function to pointers. Just showing you an example. For example, now in here I have 4 different functions. I create an array of 4 functions, function pointers, and I'm setting the first one to add, second one to sub, third one to mul, and the other one to divide. And then when I go through the function calls in an array, different functions are called in every loop. So this is just the function pointer array, as you see. So first plus, minus, multiplication, and so on and so forth. Okay, so that's that. Do not disturb. You'll only get notifications for urgent. What the? Oh, I'm in a meeting. Anyways, yeah. So let's save this as func ptr array. Another thing to note that you know that I could change this division to a template now. I can say template division TA and TB. So essentially anything that division is defined for, it can be used using a function template, right? You can have function pointers that are templated to it. Does not make any difference. For example, if I want to do a sort, if I want to do a sort that is templated, and I want the ascending and descending being decided by a function that I'm passing through it, a pointer to a function, all I need to do is to create a template for the sort. Obviously the element type is a T, and the comparison functions are two T's that are being passed, or it could be T reference, whatever you want. It doesn't make any difference. And now, using this sort mechanism, if I go up, you'll see that I actually have ascending created with T and T, and descending is created with T and T. Therefore, when the function is called for series of integers, automatically ascending for integer will be created, descending for integer will be created, sort will be created for integers, and display will be created for integers. And they all work perfectly together. Again, so pointer to functions, but the only thing is that when you are passing, when you want to pass the function address to the template, you need to, because now you are not passing any arguments, it's only the name of the function. Because of that, you have to add the signature to it. But the concept is the same, and it works exactly the same. It does not make any difference. Which is working properly now. Ascending and descending, and so on and so forth. Okay, so func pointer template. Now, as I mentioned, this is a complete violation of object orientation. Like you don't want to do something like this in C++. So how does C++ handles this? How can we pass logic in C++? I want to pass a logic to another logic. How can I do this in an object-oriented way? C++ says, isn't that parentheses in front of the thing an operator that does a function call? So just create a class and overload that. You don't need to pass anything. The object is going to hold the action that you want, and you can pass it around. So what does it mean is this. I can actually say, I'm going to come in, which one is good to go to? I'm going to do the one with B. So I'm going to, first let me show you syntax. So the syntax is like this. Let's say I want to, pass point. We had we had a function called sum that I wanted to pass it around, right? So C++ says, instead of passing the address of the function, create a class called sum. Now, this sum class can hold a method. And because when you pass an object, the methods would go with it, the method can go pass by this one. So what do we do? In here, we're going to say, I want this to, when it's called like a function, I want it to sum things up. So I'm going to say, overload the operator for function call. And because it's sum, it's supposed to receive two integers, right? So I'm going to write over here integer left and integer right. Something like that, okay? Or, yeah, oh, who cares, whatever the name is. And it's going to return an integer. So I'm going to overload this and write return left plus right, correct?
Okay.
Somebody ask a question? Did anybody ask a question online? Anyways, so now that I have this sum in here, if I want to use that function, I have to first instantiate sum. So I'm going to say, I'm going to create a sum, and let's call it lowercase sum. So the lowercase sum is an instance of sum. Now I can say integer, A and B, and yes? Chidinma? Your microphone is
wait.
on. You have a question?
Oh, sorry.
Oh, don't be.
No.
That's okay. Mute yourself. Okay. All right. So now in here I can say A is set to sum of B and 10, for example. So see what's happening over here. This sum looks exactly like a function. Why? It's an object of class sum, right? When I am calling the overloaded call function, it calls the overloaded function and passes the stuff. Now I can change anything that I want and pass instances like that to it. So this essentially, and I can do other stuff too. I can do cool stuff like, for example, integer number, and I'm going to set this one to 0. And I can say over here, say NO++. So I can even count how many times it's being called. So these, by the way, this is called a functor, okay, or a function class, all right, or a function object. So this functor, the good thing about a functor is that functors are class. So the method that is overloaded over here for function call can now have a state. A function doesn't have a state. A function is called and it's done. But when you are changing it to a functor, now you can control and keep track of stuff in it. And in here, for example, I'm going to do some, like, let's change this one to, let's say, size T and O. And in here, I'm going to say operator size T const, and I'm going to return an O. So what happens in here, I'm going to go see out A. So now, if I call this 4 times, I can say number of calls is size T of sum. So first of all, it calls the function and does the sum thingy that it's supposed to do. but also I can actually keep track of how many times the function is called. Now, my logic is encapsulated in an object. If I want to do validation, I'll pass that one around into a class. But how actually make it to be different types of validation properly, I'll explain later. We have to go back to our OOP345 knowledge to explain that. So this is essentially functors. All right. All right, so let me just take a look at this for a second. Now I'm going to quickly go through all the little things we need to know about functions. And for your lab, when you're coming in, I'll give you proper examples on it. So you can actually see how everything's set up. And yeah, so let me just take a look and see what are the things I need to cover in here. So first of all, after C++11, the functions actually can actually use inferred type too. So you can put auto in front of a function, and based on the return type of a function, automatically the return type will be decided after C++11. So you, instead of just writing integer sum, you can write auto sum. When you are returning the sum of 2, it will be automatically what you want. So that's a good thing. And also, we have trailing return types, which essentially allows you to bring the return type of the function to the end side of the function. So therefore, you can actually tell to the compiler can see the return type after seeing the arguments. It couldn't do that before. You had to know what the return type is before the arguments are met by the compiler. Now compiler can start with auto, name of the function, the arguments, and then get to the return type, which is going to help a lot. You will see it in a second. So as an example for this is like this. So I have a class ticket over here, and I create an inner class enumeration for it, for adult and child, for a ticket. Now I can have void set ticket and set the ticket to whatever it is. And then I can say auto get, and the return type, I'm going to say it's going to be a ticket type when it's returning. So the line number 10 is inferred and trailing return type. And as you see over here, when we are coming out now, obviously you see the implementation of the get, and even for the operators, you can it works the exact same way. So in here, you can actually write over here auto. Don't do it if you don't have to. I would never ever write something like this. It doesn't make sense. Like, if you don't need to, don't do it. And I'll show you when you actually need to do that. Now you don't need to. The places like for example, if I wanted to get the ticket type and display it, so get actually returns the ticket type, right? So I could do something like this. I could say auto, and I could say ticket type is set to a.get. Okay, so now I don't, because that ticket type is a part of ticket, I have to write ticket, scope resolution, ticket type, and it makes it shorter and quicker. So it's easy to do it that way. So that's one of the places that auto can be used very easily. This is where you really need auto and you really need trailing type, and I'll explain to you why. Imagine that you have a template that has two types in it. And in here I'm returning add of t for the first argument and u for the second argument. So when t and u are added together, the type may change. If the first one is an integer, second one is a long, return type will be a long. If first one is a double, second one is a float, it's going to be a double. If first one is a character, second one is a float, it's going to be a float. So the return type may change. Because of that, I will say auto add, and I put the arguments, then I say, compiler, declare the type of this operation. Because compiler is parsing it, when it reaches to this point, it knows that result of this operation will be double or whatever. So essentially, this declared type will change to the type that is going to return. Therefore, the return type of a template will change based on the arguments that it has. We could not do that before C++11. In C++11, we had to decide if add is returning a double, int, or whatever. Now, the return type of a template changes. And because of that, you have no idea what the values are going to be. So if now you want to get the result of something in add, what you do, if you don't know what the types are, you simply say auto return sets to add of I and X. Because you don't know what add is going to return. This is very simple. Obviously, you know, because it's an integer and a double, it's going to be a double. But imagine it's something in standard template library and you're passing a train and an automobile to it. You have no idea what the return type is going to be. For that, it is necessary to do this to literally get what the values are. Are we good? Online people, are we good? Yeah. All right. Thank you. Okay, so okay. Another thing about functions, we learned when we're talking about variables is that if I have a file scope variable, I can prevent that file scope variable to ever be global. If you have a file scope variable and somebody in a header file put a name of the variable with an extern in front of it, then variable will be accessible everywhere. If you want to prevent that, you can define a file scope variable as static. Making it static prevents it to be externaled, okay? If that's a word. We can do that with functions too. Say you have display in two different modules. Say you have display in two different modules. Say you have the display function in two different modules, module linkage A and module linkage B. And you don't want this displays to be globalized if anybody adds by adding its prototype to a header file. Or maybe there is another module who has a display that has a prototype in a header file, and you don't want the displays to get mixed. If you want to do that, you can simply create the display that this module is using only and is not supposed to be exposed to outside of its module with a static. Therefore, display in module A will only be accessible to module A and nowhere else, and display in module B will only be accessible to module B, and they have nothing to do with each other. Compiler will not complain that you have two functions with the same name. Got it? sometimes when you, let me just check something in here. Yeah, sometimes I'm bringing a slide in here. Sometimes things are made up of smaller versions of itself. Think about a tree. When you look at a tree, when you really look at a tree closely, a tree is made up of smaller trees as branches. If you actually cut a branch and put it in the ground, it looks like a smaller tree. You understand what I'm saying? Okay. We have that situation in programming too. For example, think about the game Hanoi Towers. What is Hanoi Towers? It's a game that says I have series of discs or rings sorted on a pole. That's number A. Then I have pole B and I have pole C. The game says I want you to move all the rings from one pole to another with two rules. Number one, you can, three rules, or two rules. Two rules. Number one, you can move one ring at a time. Number two, you cannot put a bigger ring or disc on a smaller one. And that's the rule. When you look at this, you would say, okay, this is essentially is defined by itself. When you look at A is a Hanoi Tower with 4 rings, right? So essentially, it's a 4-ring Hanoi Tower is a 3-ring Hanoi Tower with 1 extra ring. So if I knew how to solve this problem, I could simply say, I will bring the 3 following the rules to pole C. Then I will move that single one to pole B. Then I will follow the rules again for the 3 and put the 3 back on B, and therefore everything is moved. So essentially, something like this. First, I move the 3 over here, following all the rules. Let's say somebody who knows how to play the game, you call them and say, hey, using Hanoi Towers, move everything over here. Then you will move the single one over here and use the same thing, put it back, and problem is solved. This is called recursion. Recursion is when few rules can be applied. First of all, you know what to do at the end. If you reach the end of the range of the things that are supposed to cover, if you know what to do with the last one. That's number one. Number two, having X number of solutions to do something, you can reduce it by 1, and you can say X minus 1. If I know X minus 1, I can make the X happen using that. It's very easy, like with factorial. Factorial of a number is numbers that are multiplied, a number that is multiplied to all the numbers before it. So if I say, what is a 4 factorial? You're going to say 4 factorial is a 3 factorial multiplied by 4. So you essentially using n minus 1, you can find out what is n easily. And also, when you get to the n, factorial of 1 is 1, done. So you know what is the last one. You know what is the beginning, and so it becomes kind of a transitive thing. If you have 1, then 2 can be done. If you know 2, then 3 can be done. If you know 3, and it comes forward to all of them. Okay? So that's that. So if we apply that to our coding, we can actually write the code for it using the exact same thing. So I could actually do this. I could say, I want to write a function that solves the Hanoi Tower game for me. So I'm going to say, I'm going to have Hanoi, that's the name, for n rings. Okay? And I want to move from the A pole to B pole using C pole. That's exactly what we have drawn over there, right? Now, the very first thing that I'm going to say, if n is not equal to 0, I need to solve this problem. Other than that, the problem is solved, right? So if n is 0, my function is done. I don't need to do anything. But for anything other than that, what I need to do is this. First, I have to call the Hanoi function for n minus 1, right? I have to move everything from A to C. Remember that? So I have to move everything from A to C using B. That's essentially what it is, right? I'm moving everything from A to C using B. That's what I'm doing. After doing that, all I need to do is to move the ring move the ring number n, because now I have that one, from A to C, and I'm done. Right? So it actually, and then after that, I move all those things back to, so what I will do over here is this. I'm going to say, now let's go Hanoi again, and now I'm going to say n minus 1. I'm going to say from B to C using A. And I'm done. Sorry, this is A to B using C. No, that's actually correct. That's correct. A to B using C. And this one is going to be, I'm going to move from B to, sorry, C, I put it on the last one. I'm going to put it from C, then I'm going to bring it back to B using A. That's correct. Okay. So with the first one, I'm going to get n minus 1. I take it from A, and I'm going to put it on B using C. Then I'm going to come over here. I'm going to say, now that everything is on C, first I'm going to move everything from A to, that's going to be B. Named it incorrectly. A to B. That's right. Okay. Now I'm going to move that single one to B, and then I'm going to move everything back from C to A. So essentially, this is what I'm going to do. Coming back over here just to show you what I've done. Where is it? Where is it? Where is it? Where is it? I'm going to bring this one that is smaller so we can actually see up here. So I want to move everything from A to B using C. So first, if I have nothing to do. Then I'm going to move everything from, so this is what's going to happen. I'm going to move everything from A to C. and then I'm going to come back over here, move that single one, then come back over here, and put everything. Oh, so it goes back, sorry. So this one, this one, this one, and this one. And it's going to be all gone. So now, if I actually run this program, say I have Hanoi, 4, and then from A to B, using C. If I run the program, it's going to literally tell me what to do. Ring 1 to AB. So as running this, you will see this will happen. And we'll be done. This magic comes through the thing that I told you about math. So this is called recursion. Now, actually, in a high school, a long time ago, they did this experiment. To the students of that class, they didn't teach any loops. They did everything recursively. And those students couldn't do any loops anymore. They did everything through recursion. And recursion is very simple when it comes to coding, as you see. If I show you the code, non-recursive code of this one, you're going to see it's a very long thing. So coding is very simple. But the problem with recursion is that it's extremely expensive. So in here, as you see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. For 4 rings, I had to call these functions 15 times. Not 15 times back to back. I had to call it recursively, which means all the instances of the function remain alive. Because of that, it uses lots and lots of memory. So, and for example, all the compilers that you have, they're all recursive. Because each statement is made up of other statements and out of other statements, so it recursively parses it, and that's why it's so. So yeah, so that's that. So let's have this. IJ. And another simple example for it is factorial. Okay, so as you see with factorial, I'm saying factorial of a number is essentially the factorial of that number minus 1 multiplied to the next one. And I will stop when it is when it reaches to 2. As simple as that. So that's going to calculate the factorial for you. A good news is that I'm just introducing to you the recursive function. So if you see it somewhere, you don't think that it's a mistake a function is calling itself. It's not a mistake. That's what it is. You're not going to be tested on this. Maybe a very simple walkthrough. Do a factorial 3 and see the walkthrough, and you'll see what I mean. Very simple. The one that you can actually be asked to write is in DSA, data structures. Recursion is taught in data structures, not here. We don't deal with it. Next thing, reason that I'm going to the end is, that I'm ending the class early so I can get to the other one. Okay, the class ends at 3:15, correct? So I'll try to finish it in 15 minutes. So the next thing you need to be exposed to, and this is something that you're going to use a lot in this subject, will be what we call lambda expressions. Sometimes you want to write a little function that is only used at a specific place and you don't want to use it anywhere else. Going back to the first example that we had for the function pointers. Take a look. In here, I am using is adult function. You see that? I'm never going to use it anywhere else. Why do I have to, have it something like that? Makes that thing exposed so nobody else can create a function with that name. And that function is only used here. I have to make it static and writing it separately. When somebody does like this, they have to go and see what the code is. Tough. C++ has the capability of creating small functions in variables. Functions that are so small that they don't have a scope. They actually exist in other functions. And how is it done? So the syntax for it, the syntax of a lambda expression is like this. Syntax of a lambda expression is like this. You have square bracket capture list, parameters, what the return type is, and the body. I'll explain it to you. I'll write a code for you that's much easier to understand. So, say I want to create a function that says hello, and that's it. So I'm going to say auto hello, okay, equals to. I'm going to say this is a lambda. So that means, hey, a function is coming. Okay? Then I'm going to say over here, no parameters is passed to it, and the body of the function is like this. I do have iOS tree. Okay? Now, in here, what I can do is to say hello. This function exists in main and nowhere else. Very good? So, now, what if I want to say bye 10 times, okay? Or anything else. I want to give you a good example for you over here. So this is the syntax for it. Let's do something else. Let's say I want to add to a number. I want to add or double a number. If I want to double a number, what do? I'm going to write over here auto, double it, I'm going to call it, okay? Now, double it needs to receive an integer, some value, okay? And what the value would be, return 2 multiplied by value. As you see, I do not have any trailing type over here. You see that? I do not have any trailing type over here. So it will even work without it. Whatever it returns, that's going to be the auto thing that you have. You can explicitly mention what it is. There's no problem with it. You can actually do something like this. You can do that. Now, the value that is returned is double, which means this 2 multiplied by val will be casted to a double before returning. But if you want to have a return type, you can write it specifically what it's supposed to be. But if you don't do whatever the return is, that's what you're going to see. So in here I can say C out, double it, 30, and that's going to my functions are did control. There we go. That's going to say hello and a 60. So it's essentially running that function, okay? Now, to show you why is it good, take a look at this. So this is going to be, why is it giving me, oh, okay. Alpha A. So I'm going to JKL lambda intro.cpp. Now take a look at this. Remember this function thingy that I have written in here? Control A, I'm going to copy it. And I'm going to come back over here. So why am I supposed to have a function to return the thing? It's too big. Instead of that, I'll remove it. Or just let me show you what I'm going to do. I'm going to come over here, right in here. You see that? In here, I'm going to say, this is a lambda, receives an integer. Okay? And the body of my lambda is returning its exact same thing. So I don't need this anymore. If I'm getting an age, it is supposed to be between 18 and 65. So I literally create the function in the argument list of it, and after that the function is gone. Bye-bye. There is nowhere else. When your main is finished, that logic is thrown into garbage. Same thing for the other one. It's very easy actually to write. You can just copy this, copy, and bring it to valid number of students, paste, and simply take the name and return type out and put a square bracket instead. There we go. Done. So it's receiving an integer, and that's what it is. Are we okay with this? Yes.
Why are we using ints on line 12?
Line 12?
Or given the age?
You're talking about this one?
No, int age. The left side?
Yeah, because I'm receiving an age from screen.
Isn't the function returns boolean? The lambda function?
Lambda function returns Boolean, but that's the, this is a pointer to a function. It's returning the logic. So in here it's receiving it is valid. Is valid becomes this function. Goes to int, and get int does everything and return an int. That was at the beginning of the session, teaching pointer to functions. So essentially that from open curly bracket and close curly bracket, that's a function that is being passed through and is being captured by its valid argument at line 21. So line 21 is valid, is going to represent this. And it's going to return a Boolean, but that has nothing to do with the getInt function. Got it? All right. Yeah, so this, if I run it, you will see. If I run it, you'll see it works the exact same way, absolutely no difference. So when I run it, it's going to actually enter your age. If I put over here, I don't know, then it's going to tell me invalid. If I put 50 over here, it's going to work, okay? So yeah, so that's lambda in use. LM. The next thing is actually to see, we had that one, we don't need this. We need to see what those captures are. When I said capture, what does it mean? So I mentioned capture by value. I mentioned capture list. You see this over here? Now I'm putting an assignment in here. When you put an assignment inside the square bracket for the lambda, it means the body of the lambda can access all the variables of its scope by value. So there is no k in here, you see that? But it can access it. That is called capture list. That is capturing by value. And capture by value. Okay? And if we put an ampersand in there, then it means capture by reference, which means now you can actually change the values outside in the function. So the function body, the values inside the lambda belong to lambda. It cannot be accessed by main because it's inside the function. It belongs to itself, belongs to its own scope. But lambda can access the outer, the neighboring variables and entities using ampersand as a reference, so it can actually change the value. So this is capture by reference. So just to see what these captures mean, I'll put this one over here for you. So I'm just going to create it in here. So if you have equal is capture everything by value, ampersand capture everything by reference. If you have equal ampersand something, it means everything is by value, but x is by reference. And you can have more, 3, 4 commas over there. It doesn't have to be only one. Now everything's by reference except x that is by value. And this means capture the current object. And that's it. Those are all the things that you can do with lambda. Okay, let's see what else we have in here. Capture by reference. That's it. What did I miss? Let me see. Because the other class I didn't have enough time. We had to run out. How come we have enough? And the rest of the stuff that we're going to talk about is going to be on the next day. You're coming in with examples. I can actually show you examples now. I can do that. Yeah, I can do that. We have around 10 minutes. Yeah. So the example, okay, I can show you the examples. Yeah, let me do that. So let me bring the examples here. There we go. So let me bring all these, copy, and I'm going to put it all over here. So open folder. Okay, so let me start adding projects to this to see what's going on. So the very first example that I have is the basic thing that existing. I need to go here. Existing project. So take a look at this. I have an integer.h, so I want to create a smart integer value. A value that can validate itself and tell everyone if it's valid or not. So int is a class representing an integer, and it's going to get some values, put some values, and be able to show itself and so on and so forth. Very simple and straightforward. Now, bring this down. So what the validation over here is doing is essentially returning a Boolean, and I wrote this thing all with trailing thingy as a practice to see what it is, but you don't have to make it this way. Anyway, so in here I'm saying it's valid returns a Boolean, checks the value between 0 and 100, so valid mark or whatever. This is a very limited thing. It's not a good thing because this integer can only be used for marks. My validation function over here can only be marks and nothing but that. We're okay with that? And when I do a get, what get does is that it essentially does a validation based on what we have over there, and if the validation doesn't pass through, we do whatever we are supposed to. So it's essentially does the validation on the value that it's receiving. Are we okay with this? Any problem with this? And display is just displaying, and that operator is doing the get and so on and so forth. So get does a do while, receives it, checks the validation. If validation is okay, it gives and it says invalid thing again clear. Okay? I'm not doing foolproof validation, just an example. So this is a bad one because validation is something that it has to be, and I cannot change it. Now, let's go one step forward. Now, let's use pointer to function to make this thing work with many different things. What did I do? Oh, I opened the wrong one. Delete, remove, remove. One more time, add project. So now let's take a look at this one. I have integer dot, do you see that? I have that integer thingy, but instead of having a method in here, private method, I actually have a pointer to a function that receives validation and the message out. Exactly what we have done over there with those pointer to functions. And it returns a Boolean, and by default, I make it null. So now I have a choice to make this pointer null, saying that this integer does not need validation. We can do that. We can actually have an integer, not necessarily it has to validate everything. So it's not only an integer, if that thing is null, I'm not going to do any validation. So when I actually look at the main, the CPP over here, you will see that when the object is created in the constructor, it actually sets the validation value and the validation. So the validation will be set. And if the validation is null, which by default it is, then my validation will not do anything. So my done will be if validation is true, lazy evaluation, return valid. So if this thing is null, validation will not happen. If this thing is not null, then the validation function will be called and everything is set and done. Okay? So now I can change the validation in my main based on what I want to do. So now in my main, I can actually have valid age, valid mark, and I can say I have an integer val that is value is 0 with valid age. Now I can set that val to do valid mark. Now it's receiving valid mark. And int can change its validation based on the pointer that I'm passing to it. Very bad design. It's not object oriented at all. It's cool, but not object oriented. Next one, I'm going to use a functor. With functors, it becomes something that is really object-oriented. Now take a look at this. I'm going to create a head of a separate module called validation. Now my functors are classes that are supposed to do something. So what I'll do, first, I'm going to create an abstract base class saying a class for validation requires to know what is the number of validations. It's a protected thing. And it requires to have a function call operator that is virtual that receives a value and sets out the message. So anybody inheriting from validation will do these things virtually. Now I create a valid age class out of that validation with minimum age, maximum age. I set the validation to whatever is needed, and I overload those. So it not only has number of validations, but it has a minimum and maximum too, with its own validation operator setting up. We good? Or I can have a valid mark that has a validation and it doesn't have any bells and whistles. The only thing that it has over here is to check to see if it's between 0 and 100, because it's not going to change. So now my hierarchy over here is complete. I'm not going to show you the code for it. Please go take a look. You know what it is. It's just validation that I'm writing in a class, and it's very straightforward. A quick look at it just to see, seriously, to see what it is. The validation operator does for the valid age, checks the minimum age, maximum age, sets the message out, sets the result to true. Mark only checks between 0 and 100 and returns it. Simple functors created over here, but the most important thing between these is that they are children of validation. So in my integer now, what I will do, I will say I have a pointer to a validation class, and because it's a pointer, I can, and it's an abstract based class, so there is no validation class. It has to be its children. And because the validation function is virtual, automatically the proper validation will be called. Therefore, I can actually, so my integer works exactly like the other one. So the logic is exactly the same. The difference is that instead of receiving a function pointer, I'm receiving a function object. I'm receiving a class. And if you look at the code for it, it is very similar. So in my get, what I will do, I'm going to say if valid object doesn't exist, don't do validation. If valid objects do exist, then call the valid functions, valid objects. I put a star beside because it's a pointer, valid object, and pass the value and the message to it and do the validation for me. And if the object that is passed is valid mark, validation for mark will be called. If it's for age, validation for age will be called. Therefore, in my programming, I can create an object of calling kids age between 3 and 7, adult between 19 and 10. See, now I have a functor. It's not a function anymore. I can add states and stuff to it, make the validation look cooler and better. And valid mark is standard. I'm just going to have a valid mark. So I'm going to create an integer with val and kids age. So this val is with kids age. Then I can set it to adult. Then I can set it to mark. Or I can create 3 different objects of integer with different types of validation in it. Absolutely no problem. So this becomes with, it is actually with functors. Last but not least, will be lambda. I give two examples of lambda. Oh, the next day you are coming in. Exception, I haven't taught it yet. Exception, that you're going to come and we teach exception during our lab. So it's going to be lambda. Lambda, actually, there is no change between lambda and the pointer to function. It's the exact same thing. The only difference is that, so you see it is exactly the same thing. The only difference is that in my main, instead of creating a function and passing to it, I literally am creating lambdas. You see that? I'm saying int mark, and I'm passing a validation for mark to it, and I'm saying age, and I'm passing a lambda, huge lambda for an age validation for it. So this is literally the functions that I had over there, and I converted to lambdas. No difference. Okay? So this is using lambdas, and lambdas with capture. I'll go through it and you'll see. But anyways, the examples are there. Please go browse and see how they work. They're very good example of seeing how all these different functionalities are going to work. Questions? Yes.
Is there a Teams channel that I missed?
Oh, definitely. There are two teams.
I select this class enter the week 1. I think I missed the.
So send me a message on Teams. Tell me, add me to the channel.
Okay.
And I'll add you to the channel. And then you'll be fine. Please send me a message. Do it right now as soon as so and tell me I joined late. Please add me to all the teams and stuff. So I'll add you everywhere. Okay? Any questions? Suggestions? Objections? Thank you very much for joining. Have yourself a beautiful day.